So let's start with a quick overview of Cisco FabricPath. So Cisco FabricPath is an evolution to spanning tree and VPC and really changes the game when it comes to layer 2 forwarding. So FabricPath brings along with it many of the benefits of layer 3 with the simplicity of layer 2 configurations. In the past, large layer 2 networks have had challenges, large failure domains, broadcasts, etc. FabricPath provides active bandwidth, scale, and availability, and many of the concepts of layer 3 are now brought to layer 2, so essentially we can create larger, more operationally stable layer 2 networks. So you'll see here that some of those benefits, multipathing, fast convergence, the scalability of routing, we're bringing those to layer 2 when we implement FabricPath. So what ultimately does FabricPath really get us? FabricPath, first and foremost, is the reduction and elimination of spanning tree altogether. It gives us better stability and convergence characteristics. Our configurations from a layer 2 standpoint are much simpler in a FabricPath topology. We can leverage parallel paths in an ECMP-like fashion with FabricPath. Latency and throughput is very deterministic across the fabric. And we have this concept of VLAN anywhere, where we have flexibility, layer 2 adjacency, and VM mobility. Ultimately, FabricPath gets us a lot higher resiliency and higher network convergence. So let's cover some of the forwarding components in the control plane of FabricPath. So FabricPath has several key control plane elements. The routing table, it has a concept of what's called a multi-destination tree, and then lastly it has an mRoute table. So FabricPath implements from a control plane standpoint what we can call a plug-and-play ISIS configuration. Now, I know I might be scaring some folks when I say ISIS, but with FabricPath, it all happens under the hood, and you really don't have to know anything about ISIS to use Cisco FabricPath. It's not exposed to you from a configuration point of view. Again, there's no complex configurations needed, and in many cases, to deploy FabricPath in its simplest configuration, instead of the command switch port mode trunk, I can define switch port mode FabricPath, right? So the configurations can be very, very simplistic. We'll get into that in a little bit more detail later on. Also, with ISIS, right, you might be thinking, do I need to do things like define different levels, etc.? No, you don't have to do any of that, but you get all the benefits of what ISIS gets you. From a control plane standpoint, FabricPath also supports equal cost paths between any FabricPath switch in the topology. And in the FabricPath domain, we use the FabricPath routing table. Ultimately, what the FabricPath routing table gets us is a database of switch numbers, or what we call switch IDs, and the corresponding interfaces to reach these switches. Later on in the lesson, I'll go through some forwarding examples for FabricPath so you can get an idea of how FabricPath would operate with host communication from point A to point B. So a little bit more about the FabricPath routing table. Again, the FabricPath routing table contains shortest paths to each switch ID or SID based on the link metrics and the path cost. The FabricPath routing table also gets us equal cost multipath supported on up to 16 next hop interfaces at this time. So as you can see here, we have one best path to reach switch 10, right, from switch 100, and that's via interface L1. However, for switch 100 to reach switch 300, we have 4 equal cost paths, L1, L2, L3, and L4, right? We can use all of our spine switches to reach another leaf switch in the network. So that's another key characteristic of FabricPath. We want to create what we call a spine leaf architecture. So when we're looking at the switches here at the top, these would be considered our spine switches, where the switches at the bottom would be considered our leaf switches. It's here at the leaf layer of the network that we attach servers, devices, etc. The spine switches should simply serve as forwarding points for other leaf switches. You shouldn't have servers and other devices attached to the spines of the network. So now let's discuss FabricPath multi-destination trees. So for multi-destination traffic, Ultimately, you need several trees to ensure that that multi-destination traffic gets forwarded correctly without duplication. These trees are rooted in key locations inside the fabric. If you think about layer 3, particularly multicast in the way PIM operates, it builds shortest path trees. So the similar logic applies here to FabricPath and how FabricPath is building a tree. So even though we're not using spanning tree here, right, we're ultimately still building trees. And you can configure and build multiple trees by placing the root switches in an L2 fabric in different locations. All the switches in this layer 2 fabric do share the same view for each entire tree. And then ultimately, when we talk about the FabricPath data plane, we'll talk about how trees particularly are decided and how that's forwarded. But essentially at the edge switch will determine which tree to use as it adds what's called an F tag to the header, right, to determine, and that F tag corresponds to a particular tree. Again, an example up here gives you some topology information about two trees. We'll call tree 1 F tag 1 and tree 2. So here's our physical topology here, with S10 being the root for tree 1 and S40 being the root for tree 2. And then we have several leaf switches underneath here. You can see how this tree is built out for each one of the trees. So again, S10 from a logical standpoint is the root, with a path to switch 100, switch 200, and switch 300. And via switch 300, I now have a path to switch 20, switch 30, and switch 40. Now you can see the same thing with tree 2, right? Switch 40 being the root, switch 100, switch 200, and switch 300 being our leaves, and a path to switch 10, 20, and 30 as our best path through switch 100. So this gives you an idea about multi-destination trees within the FabricPath environment.